Hey guys, in this video we're going to talk about how to multiply rational expressions. These are the two types of problems that we're going to be working with. One where it's in factored form and one of them where it's in standard form. Now in both cases we're going to be multiplying two different rational expressions and our goal is to be able to simplify this as much as possible. Now before we do that, let's take a look at this quick warm-up and let's see if we can remember how to review or how to multiply two fractions. So press pause and try doing this in a separate page so that you can try to see if you can remember how to do these types of principles. Okay, so I'm going to review with you how to multiply fractions. The first thing you want to remember when you're multiplying fractions is that you want to multiply across. So in the first example, we can multiply 2 times 3 gives you 6. 3 times 5 gives you 15. And then to simplify, the numerator and the denominator both have a 3 in common. So we're going to divide by the 6 by 3 to get 2, and the 15 by 3 to get 5. Now, in a different way, we can also just combine and leave it in factored form. So the numerator would have 2 times 3, and the denominator would have 3 times 5. Now, I notice that the numerator and the denominator both have a 3 in common. So I'm going to be able to cancel these out. And I'm going to be left with also 2/5. I'm going to try doing this other example as well. Also in two different formats so you can see which method you prefer. Knowing both of these methods is going to definitely help you with the examples that we're doing today. So I can start by multiplying the top. 8 times 1 gives me 8. The denominator, I have 12 times 5 gives me 60. I notice that the 8 and the 60 are both divisible by 4. So if I divide the top by 4, I get a 2. And if I divide the bottom one by 4, I get a 15. So this comes down to 2/15. Now, and the other way to do this is you can also take these out and write it in factored form. So the factors of 8 are 2 times 4. So I'm going to write this as 2 times 4 times 1 for the numerator. And the denominator, 12, has factors of 3 times 4 as well. So I'm going to write the denominator as 3 times 4 times 5. Notice how the numerator and the denominator both have a 4 in common. So I'm going to go ahead and cancel these out because they simplify down to 1. And in the numerator, I'm left with 2 times 1, which gives me 2, and 3 times 5, which gives me 15. Again, knowing how to do these two types of fractions, how to multiply it in either factored form, like we did here, or by multiplying the numerator and the denominator, is going to help you solve these problems as we move on with rational functions or rational expressions. So let's go ahead and try this next one out. Here we have a rational expression here on the left, where we're multiplying these rational expression times this other rational expression. So if you want, why don't you go ahead and pause this video and give it a try. See what you would come up with. See if you can come up with something similar to the examples we did as a warm-up. Alright, so I'm going to solve this problem with you. I'm going to start by combining all the numerators together because I'm going to be able to multiply them across. And then I'm going to multiply and combine the denominators as well. So in the top, I'm going to have this very long expression. I'm going to have 3 times x plus 1 times x minus 4 times 8 times x plus 7 times x minus 1. In the denominator, I'm going to do the same thing and I'm going to multiply everything together. I have 14 times x minus 6 times x plus 7 times 6 x plus 1 times x minus 3. Now, I realize here that we have several common terms in both the numerator and the denominator. In the numerator, I have this x plus 1 right here, and I have an x plus 1 on this other side as well. So those two are common terms. So I'm going to go ahead and cancel these out. In the same form, I have an x plus 7 over here and an x plus 7 over here. So they're both going to divide as well. And I'm going to cancel those out. Sorry. Now that the expressions are also in simplified form, I can also see that the numbers are also going to be divisible with each other. This 3 and this 6 can also divide each other, as well with this 8 and this 14. So I'm going to simplify some of these numbers. I'm going to first simplify 3 and the 6. This one's going to come down. If I divide the 3 by 3, I get a 1. If I divide the 6 by 3, I get a 2. I can also simplify, while I'm here, I can simplify the 8 and the 14. They're both divisible by 2. So I can do 8 divided by 2 gives me 4. 14 divided by 2 gives me 7. Now, before I continue to solve my problem, I also realize that the 2 and the 4 are have a common denominator, or they're both divisible by 2. So I'm going to divide the 4 and the 2 by 2. This cancels down to 1. This cancels down to 2. Okay, now that I've simplified all of the numbers and all of the expressions as much as possible, I'm just going to multiply what I have left over in the numerator, bring it down, do the same thing with the denominator, and call it a day. So here's my solution. In the top, I'm left with 2 times x minus 4, x minus 1. And in the denominator, I'm left with 7 times x minus 6 times x minus 3. And here's my solution. That's pretty much it. Notice how I have nothing in common anymore. No numbers, no coefficients here in the front have any common denominators or common factors. None of the expressions here on the side are also divisible by each other. So this can actually be my solution. Now, if you want to do box method and combine all of the terms together, you can also do that as well. You can do box method and then do distributive property, and you will end up with something a little bit more complex, but the same solution. And we would have something like this: 2x squared minus 10x plus 8. And in the denominator, I would do the same thing. I would do distributive property and box method to get 7x squared minus 63x plus 126. Either one of these solutions is going to be fine with me, but just know that leaving it the way that we start doing it is just fine. So this would be a very acceptable solution, but whichever one method you prefer would be fine with me. All right, so let's do one more example. Here you have it in standard form, where you would first have to find the factors of the numerator, the denominator, and this denominator. Find the factors and then see what cancels each other out. So why don't you go ahead and stop this video, try it on your own on the side, and see if you get the same solution. Okay, so I'm going to factor these out, and I'm going to solve this with you to show you how to find the solution of this rational expression that is in standard form. So we have to just do one extra step and factor it out. I'm going to start by taking this guy and moving it over here, and I'm going to factor it out. Just to help you review real quick on how we factor, we have the x squared minus 7x plus 10. So I'm making my columns. The factors of x squared are x times x. The factors of 10 are 2 times 5. But since I'm looking for a negative 7, I need to make sure that this is a negative 2 and a negative 5 to give me this positive 10. So I'm going to put a negative here, a negative here. When I cross multiply, they should add up to negative 7x. So my factors for the numerator is x minus 2 and x minus 5. Now, you can do this for every single one of these numerator, denominator, and the denominator. You can do the exact same thing that we just did, make sure that you add a 0x here in the middle if you want to do that one, or you can do the difference between two squares, which we spoke about earlier before spring break. But now what I'm going to do is I'm going to write everything in factored form, and I'm going to start canceling some stuff out. So, in the numerator I have x minus 2 times x minus 5 divided by x minus 2, times x plus 2. On the other fraction, I have an x minus 2 divided by, if I find the factors of this one, it'll be x minus 5, x minus 5. Now, I can combine everything together. The numerators stay together, the denominators stay together, or I can just see that some stuff is going to already cancel out. So if you notice, the numerator and the denominator have common like terms. Here I have a x minus 2 and an x minus 2, while on the other side I have an x minus 5 and an x minus 5. Now when I combine everything in the numerator and everything in the denominator, I'm just left with x minus 2 divided by x plus 2 times x minus 5. And this is pretty much our answer. Nothing else can simplify. There are no common terms in the numerator or denominator. We're pretty much done. Again, if you want to expand the denominator and you want to write this in standard form, you could do box method, right? And by doing box method, you can get a similar answer that looks something like this. X minus 2 on the top, because there's nothing to multiply. In the bottom, we have x squared minus 3x minus 10. All right, guys, well, I hope this helps. Feel free to pause it, rewind it, solve the problems on your own, and now you can go online and try some of these examples that we're going to be doing together through Google Classroom. Talk to you later.